Good day, everyone. I am Melvin Bukog. Today, we discuss about Week 1, Unit 1, Introduction to Industrial Arts 2. Our topic is all about history of welding. Learning outcomes, define welding, explore welding history, and welding variety. So, what is welding? Welding is a fabrication process whereby two or more parts are fused together by means of heat, pressure, or both forming a joint as the parts cool. Welding is usually used on the metals and thermoplastic, but can also be used on wood. The completed welded joint may be referred to as a weldment. Some materials required the use of specific processes and techniques. A number are considered unwieldable, a term not usually found in dictionary but useful in descriptive in engineering. The parts that are joined are known as parent material. The material added to help form the joint is called filler or consumable. The form of these materials may see them different too, as parent plate or pipe, filler wire, consumable, electrode for arc welding, and etc. Consumables are usually chosen to be similar in composition to the parental material, thus forming a homogeneous weld. But there are occasions such as when welding brittle cast iron, when filler with a very different composition and therefore properties is used. These welds are called heterogeneous. Our next is history of welding. In modern times, the improvement in iron making techniques, especially the introduction of cast iron restrictive welding to the blacksmith and the jeweler. Other joining techniques such as fastening of bolts for rivets were widely applied to the new products from bridges and railways engine to kitchens, utensils. Modern fusion welding processes are an outgrowth of the need to obtain a continuous joint on the large steel plates. Riveting had been shown to have disadvantages, especially for an enclosed container such as a boiler. Gas welding, arc welding, and resistance welding all appeared at the end of the 19th century. The first real attempt to the top welding process on wide scale was made during World War I. By 1916, the oxyacetylene process was well developed, and the welding techniques employed then are still used. The main improvements since then have been in equipment and safety. Arc welding using a consumable electrode was also introduced in this period, but the bare wires initially used produced brittle welds. A solution was found by wrapping the bare wire with asbestos and entwined aluminum wire. The modern the modern electrode, introduced in 1907, consists of a bare wire with a complex coating of minerals and metals. Arc welding was not universally used until World War II, when the urgent need of rapid means of construction for shipping power plants, transportation, and structures spurred and necessary development work. Resistance welding, invented in 1977 by Elihu Thompson, was accepted long before arc welding for spot seam joining of sheet. But welding for chain making and joining bars and rods was developed during 1920s. In the 1940s, the tungsten inert gas process using a non-consumable tungsten electrode to perform fusion welds was introduced in 1948. A new gas shielded process utilized a wire electrode that was consumed in a weld. More, more recently, electron-beam welding, laser welding, and several solid phase processes such as diffusion bonding, friction welding, and ultrasonic joining have been developed. Our next is variety of welding process. Forge welding. This original fusion technique dates from the earliest uses of iron. The process was first employed to make small pieces of iron into a larger, useful piece by joining them. The parts to be joined were first shaped, then heated to welding temperature in a forge and finally hammered or freeze together. The Damascus sword. Ginagamit ang forge welding sa mga magpapanday o naghulma ng mga bakal na ginagamit bilang isang sandata or ating mga ginagamit sa paghiwa ng mga isda, karne at sa pagputol ng mga bagay. Arc weldings. Arc welding is a welding process that is used to join metal to metal by using electricity to create enough heat to melt metal, and melted metals, when cooled, result in a binding of the metals. GMAW, or shielded metal arc welding, accounts for the largest total volume of welding today. In this process, an electric arc is struck between the metallic electrode and the workpiece. Tiny globules of molten metal are transferred from the metal electrode to the weld joint. GMAW, ito yung madalas ginagamit sa mga trabaho kaya ng industrial na makikita o sa pag welding ng mga malalaki o maliliit na mga bakal. GMAW, gas shielded arc welding, in which the arc is shielded from the air by the inert gas such as argon or helium, has become increasingly important because it can deposit more materials at a higher efficiency and can be readily automated. The tungsten electrode version finds its major application in highly alloyed sheet materials. Either direct or alternating current is used and filler metal is added, either hot or cold, into the arc. Consumable electrode gas metal arc welding with a carbon dioxide shielding gas is widely used for steel welding. Two processes known as spray arc and short-circuiting arc are utilized. Metal transferred is rapid, and the gas protection ensures a taut and well deposit. SAW. Submerged arc welding is similar to the above except that the gas shield and replaced with a granulated minerals materials as a flux, which is mounted around the electrode so that no arc is visible. POW. Plasma arc welding is an arc process in which hot plasma in the source of heat. It has some similarity to gas-shielded tungsten arc welding. The main advantages being greater energy concentration, improved arc stability, and easier operating control. Better arc stability means less sensitivity to joint alignment and arc length variation. Thermochemical process. One such process is gas welding. It once ranked as equal in importance to the metal arc welding process, but it's now confined to a specialized area of sheet fabrication, and it's probably used as such by artists as an industry. Gas welding is a fusion process with heat supplied by burning acetylene and oxygen to provide an intense, closely controlled flame. Metal is added to the joint in form of the cold filler, while a neutral or reducing flame is generally desirable to prevent base metal oxidation. By deep craftsmanship, very good welds can be produced, but welding speeds are very low. Fluxes aid in preventing oxide contaminating of the point. Resistance welding. Spot, seam, and projection welding are resistance welding process in which the required heat for joining is generated at the interface by the electrical resistance of the joint. Welds are made in a relatively short time, typically 0.2 seconds, using a low voltage, high current power source with a force applied to the joint through the electrodes, one on each side. Spot welds are made of regular intervals on sheets metals that has an overlap. Joint strength depends on the number and size of the welds. Electron beam welding. In electron beam welding, the workpiece is bombarded with a dense stream of high-velocity electrons. The energy of these electrons is converted to heat upon impact. A beam focusing device is included, and the workpiece is usually placed in the evacuated chamber to follow. Uninterrupted electron travel heating is so intense that the beam almost instantaneously vaporizes a hole through the joint. Cold welding, the joining of materials without the use of heat, can be accomplished simply by pressing them together. Surfaces have to be well prepared and pressure sufficient to produce 35 to 90% deformation at the joint is necessary depending on the material's slab joints in sheet. And cold but welding of wires constitute the major application of this technique. Pressure can be applied by punch presses, rolling stands, or pneumatic tooling. Pressures of 1,400,000 to 2,000,000 to 800 kilopascals per square. Friction welding. In friction welding, two work pieces are brought together under load with one part rapidly revolving. Frictional heat is developed at the interface until the materials become plastic, at which time the rotation is stopped and load is increased to consolidate the joint. A strong joint results with a blast deformation, and this since a process may be considered variation of pressure welding. The process is self-regulating for as temperature at the joint rises. The friction coefficient is reduced and overheating cannot occur. Diffusion bonding. This type of bonding relies on the effects of applied pressure at an elevated temperature for an appreciable period of time. Generally, the pressure applied must be less than that necessary to cause 5% deformation so that the process can be applied to finished machine parts. Explosive welding. Explosive welding takes place when the two plates are impacted together under an explosive force at high velocity. The lower plate is laid on a firm surface, such as a heavier steel plate. The upper plate is placed carefully at an angle of approximately 5 degrees to the lower plate with a sheet of explosive materials on top. The charge is detonated from the hang of the two plates, and a weld takes place microseconds by very rapid plastic deformation of the materials in the interface. A complete weld is the presence of waves at the joint caused by jetting action of metal between the plates. So that's all my report. I am Melvin Bukog, and thank you once again.